Hey guys, this is Nurluda and I am a verified educator at an academy. Along with that, I am teaching live on an Academy Plus. It's a live platform where educators like me are taking live classes for various competitive exams. I personally teach for CSIR-NET, GATE and TIFR exam. So if you guys are preparing for upcoming CSIR-NET, GATE or TIFR exam, you can subscribe to my classes and you can join my classes on Unacademy Plus. So for that, what you have to do is take Unacademy Plus subscription and there you can attend my classes live over there. Now for that, if you put my referral code, that is n underscore huda, while taking subscription, you will get a discount of 10% on your subscription fee. There are also many offline lessons available on Unacademy. You can enhance your problem solving skills by watching those offline videos as well. So that's all from for this particular part. Now let's continue with our video.
Hello everyone and welcome to the channel. So in this particular video we are going to talk about micelle chemistry. Okay, so this is one of the important topic from your surface chemistry. As you all know that surface chemistry has a lot of different topics in it, like colloidal chemistry is different, then you have electrochemistry of the colloidal particles, and then you have different kind of adsorption, isotherm and all. So this micelle chemistry is also one of the part of that, right? So this becomes important because in the previous few years, if you'll see, especially in CSIR-NET and especially in the GATE exam, they have asked questions from this topic regularly, right? Be it 2018 or 2017 GATE, they have asked a question from this micelle chemistry, and also in CSIR-NET June 2019 exam, they have asked a question from a direct question, a very simple question. Okay, so in this particular video, what I'm going to do is I'm going to cover this particular topic in complete manner, like all the important things which you need to know from this topic, and probably after watching this video you won't need to read from any book and you will be done with this topic and you can solve any question which will be asked from here. Okay, and at the end of the video I'll also take some of the previous year's questions, so that just to make sure that whatever we have studied is it complete for the exam point of view or not, right? So let's start with it. So the video will contain two parts. In the beginning I'll just explain the topic as I usually do, and at the end of the video, like if you are my regular subscriber, you might be knowing this, that I always solve questions on a particular topic, right? So, and before starting it, it's just a humble request. It takes a lot of effort to make a particular video, so please, just to encourage me, if you are new to this channel, if you are watching this video and if you have not subscribed the channel, please subscribe it, and if you like my content, if you like the video, please give it a like, right? So let's start with the topic now. So we'll be discussing about the micelle chemistry. So micelle are see what happens. We have been already introduced to this micelles since we were in class 10th, right? So in class 10th we have studied that micelles are a molecule in which you have two ends. You will be having a hydrophilic end, and the other one will be hydrophobic end. Hydrophilic means your water, like this will be water loving end, okay, and hydrophobic means this hates water, okay, or water hating, okay, water hating end. So what does that mean? It means that this particular single molecule can have both the properties. It can get attracted towards the water, one of the end get attracted towards the water, and the other end is moves away from the water. So that's what it means. Okay, now this is called as head, okay, and this part is called as tail. So this is about a single molecule. When you have a single molecule of a micelle, okay, micelles will be like, you will be having two ends. One will be ionic part and the other one will be the organic part or the non-ionic part, right? So the organic, you can consider it. Let's take an example, and I'll be talking about, let's say, SDS. Okay, so SDS means sodium dodecyl, okay, dodecyl sulfate. So this is nothing but a sodium sulfate ion of a 20 carbon chain. Okay, so this particular thing can be expressed in this form: SO4 minus and Na plus. Okay, so this is going to be the ionic part, and then you will be having a long chain of carbon. Okay, so this chain will end up to 20 carbons. So that I'm not going to make, but yeah, this is how it will look. So in this particular molecule, this ionic part will be water, like it will be hydrophilic part, and this particular part, which is non-ionic part, that will be hydrophobic part or water hating part. Okay, so this will be your head basically, and this is the tail. So this is how in the molecular form it looks like. Okay, so this is how it looks like in the molecular form. I hope you guys are getting what the figure of, like, the image of the micelle, right? Now, so this is a micellar ion. Okay, this is just a submicellar ion or a micelle ion. Okay, now when the micellization happens, okay, this is called as micellization. Now it's a process in which these ions will like they will associate in order to form a micelle. Okay, so these ions will associate themselves, like they will associate with each other, and they will form a big associated colloid. Okay, this is what, this is associative colloid, or this is also called as micelle. Okay, so this is a name given to it. So micelle is nothing but the associative colloid which is formed by the ionic part of each micelle. Okay, so this is the basic definition. Okay, so the definition is what, that, okay, I'll just write it down over here just to make sure you guys know about it. Fine. So at lower concentration, at lower concentration, these ions stay as these ions stay as individual species. Okay, individual species, but at higher concentration, what will happen, that association of these ions take place, forming associative colloid or micelle. So this is what happens. Okay, your ions which are in the like in the lower concentration, they stay as ion, but when the concentration increases, they form a micelle. Now everything, all the properties of a micelle remains within this particular range. Okay, be it the conductivity, be it the surface tension, or the entropy. So I'll be discussing about all these three things, and all these three things actually revolve around this particular definition only, that at lower concentration they stay as the ionic entity or as an individual molecule, but at higher concentration they form associative colloid or they form micelle. Okay, so remember this thing, and in the next of the graph and everything, you will be like, these things will help you to understand the rest of the thing. Now there are two important things which you need to know. Okay, the most important thing is the critical micellar concentration. Okay, and the next important definition is your Kraft temperature. So we will be talking about both the things. Okay, one by one. So what is critical micellar concentration? As the name suggests, okay, critical micellar concentration means what, it is that particular concentration or that minimum concentration which is required in order to form a micelle. Okay, that means what will happen, see, as I already told you, that these like micellar ions or these individual ions, what they do, they form a micelle, right? But they form a micelle after association, and for association you need lot of amount of those ions, right? That means you need a big or a concentrated solution of those ions. Okay, so that's what it means. So that means you need a particular concentration at which these particular ions will be able to form a micelle, right? So critical micellar concentration is nothing but it's the minimum. Okay, it's the minimum concentration required. Okay, it's the minimum concentration required to form micelle. Okay, so it's the minimum concentration which is required, and whose concentration of the surfactant. Okay, so we are talking about concentration of surfactant over here. These all are actually surfactants. These all ions which are just shown, these all are surfactants, right? These are called as surfactants. Like all your detergents come under this particular property. Now, Kraft temperature is the temperature at which these micellization happens. Okay, so you need a particular amount of temperature also, because if the temperature is too low or the temperature is too high, then also this micellization does not happen. So you need a particular amount of temperature, and that particular temperature is called as Kraft temperature. So it is the temperature, okay, it is the temperature at which micellization happens, or you can say that the formation of micelle take place. So that's what your craft temperature is. Now how does it happens and how does it depends upon different properties? Okay, that's what we are going to understand next. Now, as I told you that this critical micellar concentration is actually a particular concentration at which this micellization happens. So how do you find out that concentration? Okay, so you have different ways to find it out, and the best or the most preliminary way is to find out by plotting a graph between the surface tension and the concentration of the surfactant. Okay, so here is a graph in which we have plotted surface tension on the y-axis and we have concentration on the x-axis, as you can see, right? So what we will do now, we will see that how this how this particular micellization is happening. Now if you see, so you just have to look upon to this particular line, okay, this line over here. You don't have to look upon to anything. So this line, just look upon to this line, and this line has a kink over here, right? This line is bending from now. So what is happening at each and every phase, that's what is mentioned over here. So at the very beginning, in the very beginning, you just have a water, okay, and that is at 20 degrees Celsius. So we have taken temperature as 20 degrees Celsius, and we have water over here. So we don't have any surfactant in this water, we just have water. Surfactants molecule are shown in this particular diagram over here in the small boxes, okay. So this is small diagram, this is small molecule is showing in this way that this dot, this dark blue dot is actually your hydrophilic portion, and this line or the single line is your hydrophobic portion, that means the water hating portion. Fine. So over here what will happen in the beginning, in the starting, that you have only water over here, there is no surfactant, so the surface tension will be high, okay, or the surface tension will be normal of a water. So the water surface tension will be here, that will be around um, around 70 millinewton per meter, okay. So that's what the surface tension will be. Now as soon as you start increasing the concentration of your surfactant in milligram per liter, so we are increasing the concentration of surfactant now, okay. As you can see, we have 1 milligram per liter over here, we have 10 milligram per liter over here, 100 milligram per liter, and likewise we are just increasing that the concentration of our surfactant by the ratio of 10, okay. So when you increase it and when it becomes 10 milligram per liter or any of the value, when you increase that concentration, so what will happen, that some of the surface molecules which were earlier occupied by water are now occupied by the surfactant, okay. So that means the water molecule which were on the surfaces, they will be replaced by the ions of this surfactant. So what is happening now, the surface tension of water will decrease, right, because water is getting replaced from the surface. So surface tension will decrease. That's why you are able to see this steep slope in the graph. The graph is just decreasing over here, okay. So as soon as you keep on increasing the concentration, your the surface tension will keep on getting decreased, okay. Your concentration will it will keep on getting decreased, and at a particular concentration, at a particular fixed concentration, what will happen, that after that, when you increase more concentration of your surfactant, there will be no change in the graph, okay. The graph will become flat means there will be no change in the graph. The surface tension has got a saturated value. So why that happened, because at this particular term, at this particular concentration, what has happened actually, so you can see in this diagram that the surface got saturated, okay. All the surface molecules have been taken up, all the surface has been covered up now by the surfactant molecules. Earlier it was in the beginning it was with the water, in middle it was water plus surfactant, but now it has been only covered by the surfactant, so no more water molecule. Now if you increase the concentration, there is nothing happening on the surface, so the surface tension will remain constant, and that's why this graph has bent over here and got flat, okay. Although this has been this has been made just to show you that, okay, you get a sharp peak, but in actual you will get a you get a curve kind of thing, okay, little curve over there. So this particular concentration, you just see the concentration on the x-axis, this concentration is called as critical micellar concentration, or CMC. So this is what the concentration at which the micelles have been actually formed. Why? Because now this is the saturation level, and after this there is no there will be no more ions in the solution, and those ions, if you increase the concentration, those ions will not be used to reduce the surface tension, they will be used to form the micelle. That's why this particular concentration is called as critical micellar concentration, okay. So this is one of the way of finding out critical micellar concentration based upon the surface tension. We'll see some more graphs related to the the graph related to the property of your micelles, and we'll try to understand that what is happening. I hope this is clear to you, right? So in the beginning, surface tension is high. When you keep on increasing the concentration of a surfactant, your surface tension will decrease because water has been replaced by your surfactant molecules at a saturated value, where all the water molecule on the surface will be replaced by the surfactant molecules. After that, there will be no change in the surface tension. The surface tension will become flat, and that particular concentration is called as critical micellar concentration, right? So this was about finding out critical micellar concentration based upon your surface tension and concentration graph. Let's take the graph for the conductivity. Okay, so let's take the graph between conductivity and the concentration. Now, before going any further, I just want to make it very clear that your like whatever structure I have shown you till now, that was in 2 dimension, right? So the micelle does not remain in the 2 dimension. Actually, it looks like this. Okay, as you can see on your screen, it's a profile of micelle. That means how it is actually being built. So these are your ions. These these blue dots are showing the hydrophilic ends, and these gray lines are actually hydrophobic tails, right? So those tails are getting buried inside, and now they are getting like the micelle is being formed. Surfactant molecule complete micelle. So this is how it will be formed, right? So in the starting structure, you can see that the micelles are like the ions are coming closer to each other, and at the end, this is the complete micelle. So this is actually a spherical shape. It's actually a spherical in shape, right? I just wanted to make it very clear that this is how your micelle actually looks like, right? Now let's go to the other properties of micelles. All right, so now we'll try to understand that how does a graph of for a conductivity uh, versus surface surfactant concentration looks like. Okay, so now you can understand that in the beginning what will happen. So the conductivity is actually the property of a particular solution, that how much amount of ions are available for making the for making the conduction of the electricity, right? And it is measured in millisiemens per centimeter over here, and the surfactant concentration is taken on the x-axis. Now when you increase the surfactant concentration, so what will happen, that initially when you have only surfactant ions, okay, though that means you just have ions in this form, so these ions will help you in the conduction, right? These ions will help in the conduction, and you will be having conduction, the conduction of the molecule, like conduction of the solution will increase with this blue line, as you can see on the screen. So this blue line is actually the conduction which you will see when you have ions, like the free ions are over there. Now after a particular concentration, you know what that concentration is. That concentration is actually your CMC, critical micellar concentration. Your free ions will be there, but many of the free ions will be forming the micelle. Okay, so it's not like that after critical micellar concentration all the free ions will form the micelle, but yeah, micelle formation start taking place. Okay, that means you will be having over here, you will be having micelles. Okay, micelles, along with that you will be having free ions as well. But you can see that the concentration of these free ions, okay, the number of free ions will decrease, right? Because in the beginning you will be having more number, all the free ions are available over there, there is no micelle formed. But over here, after this CMC, after critical micellar concentration, your sum of your amount of your your free ions, they will be forming micelles. So obviously the amount of your free ions will decrease. These are, like I'm talking about, these are the free ions. Okay, so these free ions will decrease, and that's why the conduction will be there. Okay, there will be conduction because in the solution you have this plus the free ions as well. So these free ions will conduct, but they will now conduct with a different rate. The rate of conduction will decrease, or the slope of the graph which will plot between the conductivity and the surfactant concentration, that will be different from the one which you will see initially, right? So that means what this blue curve is showing you about the conduction curve is the conductivity curve basically, when there is no micelle formed, and this red curve is actually the curve for the conduction when the micelles are formed. Along with that, the free ions are conducting and they are helping in the conduction. Okay, so that is what is happening over here. So this over here is actually the conduction between this is the graph for conductivity versus surfactant concentration, and this particular concentration is called as critical micellar concentration. Now again, from this graph or from this plot also, you can find out the critical micellar concentration. So if you need to find out critical micellar concentration, you can either measure the different conductivity at different concentration of the solution, and the graph from where the slope will change, or the point from where the slope will change, that point will give you critical micellar concentration, right? Okay, so that's about your conductivity and the surfactant concentration, right? Now there is one more thing which you have to keep in mind, and that is the molar conductivity. Okay, so let's try to understand from the molar conductivity point of view. Now, here's a plot between the molar conductivity versus the concentration of your surfactant molecule. Okay. Now you have to be very careful about it. Why? Because see, you can see from the graph that the molar conductivity is decreasing, and why it is happening. So molar conductivity is actually the conductivity per moles. Okay, that means number of moles of particular thing. So conductivity divided by number of moles. Now what will happen that during the starting period, when you have when you don't have much amount of, when the solution is dilute, in that case you'll be having free ions, a lot of free ions, right? So those free ions will help you in the the conductivity of those free ions will be there. So that's why you are getting this high value over there, right? But as the concentration will increase, what will happen that your more of your free ions will start coagulating, or they will be forming the aggregate, right? They will be forming the associative colloids, or the micelles, right? So, or the micelles basically. So what will happen that at a particular concentration there will be decrease in this particular molar conductivity, and as this molar conductivity, like it's just like what you have seen in the conductivity. Okay, in the conductivity you have seen the increase. In molar conductivity there is a decrease. Why? Because molar conductivity means the amount of conductivity per mole. Okay, but when you are increasing the concentration, your molecules are actually not available for conductivity. They are being used in some other way. That means they are being used to form the micelle, right? So that is why what is happening, that when the molar conductivity is when the concentration is increasing, molar conductivity is decreasing. Why? Because the molecules in the starting you have free ions, and those are actually available for the conductivity. But as soon as you are reaching this CMC, this point is actually your critical micellar concentration. Now after that, what will happen, that these free ions are actually not available for conductivity, but they will be available just for what, they will be available, like some of those, some like the amount, the number of the free ions which are available for conductivity, that will decrease. So that is why this graph is decreasing, because the number of free ions available for the conductivity is getting decreased. In the last graph, what is the difference between both of them? You don't get confused between both of them. The last one was just conductivity of the solution. So the conductivity will increase. Okay, because over there you are just seeing that okay, conduction is increasing because you are increasing the concentration of the impurity, or the ions, free ions in that. So that's why the concentration, when you are increasing the concentration, conductivity will increase. But molar conductivity is the conductivity by 1 mole of molecules. So you have restricted the number of molecule, and those number of molecules are now not being available for the conduction, but they are getting formed into the micelle. So the number of availability of free ions is getting decreased over here. So that's why you are getting a decrease, or the negative slope for this graph. So remember this, that for molar conductivity graph goes down, but that means you get a negative slope for that. But only for conductivity of the whole solution, for that you get a positive slope over there. Okay, so just try to understand this thing. If you have any doubt, you can ask me in the comment section regarding this, right? So it's very clear that for conductivity we have to see for the whole solution the ions which are available in whole solution. But for molar conductivity, or we are restricted to a particular amount of free ions. We are just restricted to take 1 mole of free ions, and we have to just study those 1 mole of free ions. Okay, so when you increase the concentration, so the concentration will increase. That means you are removing the solvent. Basically you are not increasing the number of free ions, but you are reducing the solvent in order to increase the concentration. Okay, so in that way your number of molecules are fixed. So but when the solvent is being removed, and they will be concentrated, so they will come closer and they will get coagulated to form micelles, and that's why they will show less conductivity or less molar conductivity. So molar conductivity will be low, and normal conductivity of whole solution will increase, right? And this kink or this change in this graph will be shown by at the critical micellar concentration. Now these were some important things which I wanted to explain or I wanted to show regarding the micelle chemistry. There is one more factor, there is one more concept which you need to know, that is the entropy of micelles, right? The entropy during the micellization. So let's try to understand that as well. Alright, now going into the further explanation of this, I just want you guys to think about it once, that what will happen to the entropy of micellization. Okay, now you all have studied about till now about micellization, that what happens in micellization. Free ions are there, they come together, they associate with each other to form a micelle or a associative colloid. Now what you have to think is, what will happen to the entropy of the system? Okay, will it increase, or it will decrease, or it will remain equal? Okay, so these are three options, and just pause the video, think about it for a time, and write it down in the comment section that what you guys thought about it. Okay, because this is something very unusual which happens over here. Okay, see, I'll tell you very frankly that many students and many people think in a such a way that, okay, you have free ions earlier and they came closer, they associated, or they came they form an associative colloid, they form a micelle basically, so the entropy should decrease. Okay, so this is what comes in our mind. First of all, the first thing which strike our mind is this only, that the entropy will decrease, okay, during micellization, but this does not happens like that. So what actually happens over here is shown in this particular image. You can see over here that you have a solvated surfactant molecule. Okay, solvated means the surfactant molecule is over here, and all the solvent molecule is the solvent molecule will be surrounding it particularly, right? So these white dots are showing you about the solvent, like the solvent molecules. Okay, so the surfactant molecule is this with this hydrophobic green end, hydrophilic green hand, and the hydrophobic red tail, and these solvent molecules are surrounding it all over there. So this is a solvated surfactant molecule. Now there is lot of solvent molecule around this particular ion, right? So, and these all all these solvent molecule are some or the other how influenced by this particular ion, okay, by this surfactant molecule over here. So this surfactant molecule will actually influence these all solvent molecules, and it will, like, they will be hovering around that particular molecule basically. Now what will happen then when you have a micelle form? Okay, so when the micelle will be formed, in that case you will be having hydrophobic end at the center and hydrophilic heads on the sides, right? So it will be, just I have shown you that it behaves, it becomes a spherical in shape, right? So all these all the solvent molecule will now be available only at the surfaces, not along the all molecule, like not along the whole ionic molecule, okay, or not along the whole individual molecule. Now they will be just surrounding the whole micelle. So what will happen, that lot of amount of unbound water or the unbound solvent will be available over here, which will not be available to bound now, because the surface has been buried inside this micelle, right? So that is why what happened, that many bounded solvent molecules are now unbounded. So bounded means they are not free to move, unbounded means now they are free to move. So what will happen to the entropy? The entropy will increase. Okay, so micellization is a spontaneous process, and over here entropy uh, is actually entropy increases, the entropy of the system increases. So I'll explain it once again very quickly. What happens, that in the beginning you have solvated surfactant molecule, the molecule is being solvated throughout by the solvent molecule. Once the micelle is formed, you have hydrophobic end which are buried inside, and hydrophilic end which are like on the surface or forming a sphere. So now your solvent molecule are just available to hover around the surface in the spherical molecule, not till the end of that. Okay, they cannot surround it completely. So that, like, they cannot surround a particular ion completely, so they can only surround the micelle which is being formed. So there will be a lot of water which will not be available to solvate now, or that water will be available as an unbound water. Okay, now these unbound water are the only reason why this entropy increases. So the entropy has been increased because earlier you are having solvated water, or the or you are having bounded water or bounded solvent, now you have unbound solvent. So that is why your entropy of the system increases. Now this is one of the very important concept around this micelle chemistry. Okay, so these were all about all the important concepts, all the important things which you need to know about the micelle chemistry. Now we'll take some questions from previous years of CSIR-NET and GATE exams, and we'll see that how we can apply our concept to solve those questions, right? So let's solve them. Alright, so now this particular question which you can see on your screen right now was asked in GATE 2018 exam, and it was asked for 1 marks. So the question says that for an ionic micelle forming surfactant near its critical micellar concentration CMC, the dependence of molar conductivity and the surface tension on the surfactant concentration is best represented by. Okay, so where it is best represented, that's what you have to see. So we have already studied about molar conductivity and also about the surface tension. So about surface tension, we have seen that in the beginning it will decrease and then it will become flat. Okay, so first decrease and then become flat. So that's what it is. So either it can be like according to the surface tension, these dotted lines, these dotted ones are shown, like the surface tension is shown in the dotted lines. So this could be either option number C or option number B. Okay, option number A cannot be your correct option, neither your option number D can be correct, right? Because over here you have the first you have saturated value and then it is increasing. That will not happen with the surface tension, we have already seen, right? So this is CMC region. So within this critical micellar concentration region, as I already told you that everywhere you will not get a kink, you will get a curve also. So that's what it is shown, that the curve you are getting. Okay, so that's pretty sorted that yeah, surface tension will be among option B or C. Now talking about the molar conductivity. So molar conductivity also I have told you that in the beginning your conductivity will be decrease a little bit, and after critical micellar concentration your molar conductivity will decrease with a big steep, right? Why? Because now your ions are not available for the conductivity, they are forming the micelles, right? And you're talking about molar conductivity, that means you're just like you're just measuring 1 mole of the molecules, or 6.02 into 10 to the power 23 molecules into the consideration. So both the graphs are only valid in your option number B, right? See, the molar conductivity graph is first decreasing a little bit and then a steep decrease in the molar conductivity, and the surface tension is first decreasing and then becoming saturated. So both the properties are being explained properly by your option number B. Option C is not correct because over here it is shown that molar conductivity will increase first of all and then that will become saturated. That is not correct. That would have been correct if they have expressed it in form of conductivity rather than molar conductivity, right? So this is the wrong answer. So correct answer is your option number B. So that's how you have to do question, right? So I hope this was pretty much clear that how you have to read graph and solve question related to CMC or the micelle chemistry. Let's take one more question from CSIR-NET exam. Now the next question which we are going to take was asked in your CSIR uh, June 2019 exam. Okay, and this was asked for 4 marks. So see, it's an important topic, right? So it was asked for 4 marks over here. The question over here says that the above the critical micellar concentration, that means CMC, the option which correctly describes the variation of molar conductivity. See, they are talking about the molar conductivity here as well, with the increase in concentration of sodium dodecyl sulfate. So sodium dodecyl sulfate, as I already gave you example of, this is generally called as SDS, and this is nothing but a surfactant. Okay, so it's a surfactant. So I already told you that it is made up of 20 carbon chain having sulfate ion at the end and the sodium ion, right? So yeah, so concentration of sodium dodecyl sulfate in aqueous solution is, so you have 4 points. Now let's read out all the points. Okay, so point number 1 says that molar conductivity increases sharply but the solution does not remain colloidal. Okay, that's the first point. Second says that the molar conductivity decreases sharply but the solution remains colloidal. Third says that the molar conductivity decreases sharply and the dissociation into monomers also occurs sharply. The last one says that the molar conductivity increases sharply with the large loss in the entropy. So they are basically talking about the graph which you will plot between the concentration of surfactant, okay, that is SDS, and the molar conductivity. Okay, so remember how the graph was. It was having a less, like it was having a little slope, like the negative slope, and then a steep slope after CMC. So this point was CMC, right? Just to recall, just to make you guys remember. So this is how the graph looked like. So the molar conductivity, was this increasing? So no, absolutely not, right? So molar conductivity was not increasing. So option number 1 is absolutely wrong. Similarly, your option number 4 is also wrong, right? So molar conductivity was not increasing. Also, in option number 4, it says that with a large loss in entropy. So like I already explained about entropy, right? So entropy increases. There is no loss in the entropy. Basically, entropy increases. So fourth option cannot be your correct option. Talking about the third one, it says molar conductivity decreases. Fine. And second also says molar conductivity decreases sharply. Fine. Both of them are talking same thing about the molar conductivity. Now we'll talk about the solution, how the solution becomes. So after CMC, after critical micellar concentration, I have already explained that actually your solution, like the ions, they come closer, they associate, and they form a colloid, right? So after critical micellar, and these are all, everything is being asked above the critical micellar concentration is after the critical micellar concentration, or the concentration more than the critical micellar concentration. So the molar conductivity will decrease sharply, correct? But the solution remain colloidal. Solution will remain colloidal. Third one says that the molar conductivity decreases sharply. Fine, correct. But there is a dissociation into monomer? No. There will be no dissociation into monomer. It's not like after a critical micellar concentration, your micelle will break into the monomers. No, it's not like that, right? They will be forming more and more monomers. Like monomers will come closer and they will form more and more micelles. So option number 3 is also wrong because it says that the dissociation happens in the monomer. So second part is wrong. First part is correct. And for option number 2, for statement number 2, both the parts are correct. Like the molar conductivity also decreases sharply and the solution also remains colloidal. So that is how micelle chemistry is being asked in the few years of CSIR-NET and GATE exam. I hope this video was helpful to you. If you guys have any question related to this micelle chemistry, you can post that on my Facebook page, and we'll be discussing that over there, right? So the link of that Facebook page is right there in the description, and you can like join that Facebook group. Also, at the end of this video, I just want to ask you guys just a humble request that if you are new to this channel, please subscribe to the channel and give a like to this video if you like this content, right? So I hope this was a helpful video for you guys. So do give it a like, share it with your friends, and that's all for this video, guys. Thank you so much for watching and have a great day. Bye bye.